Oh, it is 10:15. Whoops. All right. Okay, so good morning, everybody. Um, we are, well, I shouldn't say we, because you probably don't think you're lucky, but I am very lucky to be here today because this morning, my neighborhood didn't have any power. So it wasn't until I think 8:20, 8:25 when power came back and my router started blinking, but then it still wasn't like green. It was just like red blinking. And I was like, oh, we have power, but do I have internet? And so I was still figuring out for about 5 minutes. But luckily, we are here today. I'm here today that I'm able to give this lesson. So you guys are so lucky to have math today. Anyway, today will be the last day that we're going to be working on. Oh, I shouldn't say the last day, but like in terms of like topic wise, um, today's kind of like the ending point. On Thursday, we'll be starting on exponentials. Now, again, I hate to say this, I really do, but because of time, we're not going to have an official review day. We're not going to have a review class. So what I did is this weekend. Let me share what I got. I have create two things on MIME CPS Classroom. The first thing is, of course, your student notes, which is for today. Again, if you click on student notes in MIME CPS Classroom, then you can go to Kami and follow along in terms of solving radicals. That's what we're going to be doing today. We're going to be solving radicals. The date is wrong on here, but I mean, that's not really a big deal that the date is wrong. But everything else is going, whoops, sorry, I think I clicked on something. But all the slides is here for today. The other thing that you will see is there is a review worksheet for our formative. The formative will be released on Wednesday. On Wednesday. Okay, so there is a formative review. Now, just like last time, I don't. This is not going to wait. This is. I definitely thought I fixed this. Okay, I need to fix this. But this is the review. There are like I think 5, 6 pages, but there's a section that's repeated. So I'm gonna cross that out. I need it. I don't know. I thought it was whatever. But anyway, this is for you. If you want to do it, that's great. If you don't, whatever. I'm actually working on the answer key right now. Okay, so I'll be posting that in hopefully by the end of today, but definitely by tomorrow afternoon. Okay, that way you can check. I would really encourage you to come in tomorrow for support and ask questions. I probably will only ask or answer general questions on Wednesday. Okay. If you have your own notes, perfect. That's awesome. I do not mind that at all. I prefer you have your own notes, but in case someone needs like a virtual environment to write down their notes so they have it, that's fine. Okay. All right. So let's go ahead and get started for today. Your homework 10, that was a practice quiz, should be done today. If not, I mean, done as soon as you can. I've gone ahead and put in zeros for those that for previous, like the first 3 weeks, I think I put in zeros, and I mean I put down missing, but by now they really should be done. If you want to use like the last couple homeworks as review for yourself, that's okay too. Or you can use the review sheet that I just showed you. But regardless, let's go ahead and apply some of the things we learned on Thursday about law of exponents, as well as our exponential form, our radical form, our exponential form for our rational exponents. Okay, so we're gonna take a couple minutes. I think simplifying these kind of things should be quick, but if you run into some trouble, no worries, we'll work through them together. Okay, so take a couple minutes to take a look. I'm gonna put a timer just so that we aren't gonna be doing this forever and ever. But that's our time here. Move this guy over there. Okay. And now during this time, you should be working through it, trying it for yourself, seeing if you know how to do it. All right. Also, just so I know I'm not all alone, can some of y'all, can you guys turn on your cameras if your camera does work? I would really appreciate that. Unless, of course, you have opted out, and that is fine. I understand. I understand. Nice. I like the hair, Sanam. You got that done this weekend? It looks good. I like it. Hello, Kayla. Thank you for turning on your camera. Appreciate it. Appreciate it. Okay, is that enough time or do we need a little bit more time? I know that was kind of quick. That's good, Kara. I like the fact that you made flashcards to help you learn the law of exponents. It's great. Okay, so no one's really said anything about if they need more time or not. I guess I'll start going over it slowly. Again, I know that we've kind of like talked a little bit about it. If you need like another run through just to get more idea of how to solve for these, that's fine, and that's what I'm here to do. Okay, but so when I have something that looks something like this, my goal is to kind of simplify what I can inside first before figuring out what to do with my outside exponent. And also, I kind of want to look at like, if I have the same basis for things, just start like getting rid of stuff if possible. Okay, so for example, I see that in the numerator, I have 2 with the base of x, 2 numbers with the base of x. I also have a term with an x in the denominator also. So I should be able to add my exponents, but also subtract here at some point. My 6 and 3 are also being multiplied in here, but the thing is, I can simplify that, right? 6 over 3, I know what that is. I can simplify that as well. So let me go ahead and begin to simplify this nasty looking thing. All right, but I'm going to start by just getting rid of the real numbers because I know 6 and 3, that's easy to deal with. 6 over 3 is 2, right? 6 divided by 3 is positive 2 in the numerator, so I'm going to go ahead and put that in first. I have x to the 5th multiplied by x to the negative 8. Because they're being multiplied here, I'm going to go ahead and add my exponents instead, like we talked about last week. And so I'm going to put x to the negative 3, because 5 plus a negative 8 is negative 3, while in the denominator, I still have x to the negative 6. You can't see what I'm typing. I'm just going to share my whole screen. Hopefully then you can see, maybe. Can you see now? Okay, all right. I don't know what happened. I'm so sorry. Okay, so this is the first step in terms of simplifying. So I first got, so because 6 over 3, I can simplify that, and I just first simplify my numerator, x's. Because now I can figure out the numerator minus the denominator. And I have all these negatives for now, but I'm not going to worry about the negatives until later, right? If I still have negative at the end, then I could worry about it, but let's go ahead and continue solving for this. Now, because they're being divided this time, yeah, because 6 divided by 3 is 2, right? It's not 1/2, but 2. And if I had 3 over 6, then the 2 would be in the denominator because it's essentially saying I have 1/2, right? 3 over 6 is 1/2, which means the 2 goes in the denominator. Okay, now here I have 2. I have x minus 3 I'm sorry, x to the negative 3 divided by x to the negative 6, I can subtract because they're being divided now. All right, so negative 3 minus a negative 6 is going to give me x to the positive 3 instead. Everything is still to the 4th power on the outside. Right, so even as I'm trying to simplify this, I'm not trying to do everything at once. I'm kind of just looking at, like, I'm looking at each base, right? So I'm looking at the real numbers, 6 and 3, and I look at my x's, right? So for each base, I do one thing and that's it, right? 6 over 3, I know that's 2, easy peasy. For the x's, I said, let me do the numerator first. Once I figure out the numerator, then I figure out if I excuse me, I can divide if I want to divide. So first thing that happened was I simplified the numerator. So x to the 5th multiplied by x to the negative 8. I first added my exponents here because they're being multiplied. Right, so once I simplify my x's, I get x to the negative 3 because 5 plus negative 8 is negative 3. From here, x to the negative 3 is divided by x to the negative 6. So here I subtract my exponents because they're being divided. And because I have negative 3 minus a negative 6, this ends up being a positive 3. Now, again, so that was for my x's. My whole number, my 6 and 3, essentially what I have is just 6 divided by 3. So 6 over 3, that's just 2. Okay, so I'm kind of like, I'm thinking about them separately, my real numbers and my variables, right? In this case, my variables, there's just the x's. So 6 over 3 is 2, and so that's why I have a 2 in the numerator. While my x's, I'm doing it one thing at a time. Numerator, 5 plus negative 8 gives me negative 3. Negative 3 minus a negative 6 in the denominator gives me a positive 3. So now now that inside the parentheses, everything is done. There's nothing else I can do here. Now I can distribute. Now it's not really distributing, but that's okay. That's what we're gonna call it, right? It's like it's distributing to each of my terms, each of my bases, right? So now what I can do is I can say 2 to the 4th power, whoops, as well as x to the 3 times 4, because what I have here is a power to a power, right? X to the 3rd to the 4th power. It's a power to a power, so I multiply instead. And so the last thing that I do is I simplify the things that I just got. 2 to the 4, that shouldn't be too hard, right? It's 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. And then I have x to the 12th. And so my final answer is 16x to the 12th. All right, so again, we go from something that was really, really gross with all these to the powers and the exponents, and I got a numerator and a denominator, but I end up with something very, very clean, right? Something that's just a whole number coefficient with x to some power, right? So I have two terms, or not two terms, I have two bases, but just a coefficient with an exponent. Very, very clean. Okay, so this one involved a lot of the laws that we learned. We had, when they're being multiplied, we add. When they're being divided, we subtract. When we have a power to a power, we multiply. But also the distributive thing. I think the only thing missing here is really to the 0 power and a negative exponent, right? Which we almost had, but I mean, we didn't have to deal with it later on. Okay, how do we feel about this first question? Again, if you can give me in the chat, in the Zoom, on the camera, let me know how we feeling. Okay, in the Zoom functions, if you can give me a yes, no, thumbs up, thumbs down, or if you can give me in the chat or on the, okay. Okay, I think I only saw like 4 responses, 5 responses, 6 responses. Okay, it seems like we need more practice with this. And I understand because we kind of went over it once on Thursday. So we will be, so today, like I said, we're going over solving radicals. If there's time, we'll go back to some of this, but otherwise tomorrow, like I said, 9th period for support, we can do this specifically, more of these problems, okay? So tomorrow during support, I would say that would be the time to come in. We can go over more of these problems to make sure we know how to do these, okay? All right. Similarly-ish, we want to be able to write this is in radical form because I actually see the radical, okay? But we want to write it in exponential form, meaning we want it in terms of a rational exponent. If you don't remember from last week, anytime I have a radical, I can write it in a fractional exponent, a rational exponent. Okay, so anytime I have a square root, it's the same thing as a 1/2 power. The cube root is the 1/3 power. Fourth root is the 1/4, so on and so forth. Okay, so we're going to be using this fact in order to change it into a rational exponent. So here, I'm going to just look at piecewise. So I'm going to look at the top, I'm going to look at the bottom. So for here, I'm going to say, okay, the top portion, my x cubed is to the 4th root. So that's the same thing as to the 1/4 power. I'm going to go ahead and first put my fraction bar. I'm going to have a power and then another power. I'm going to have x to the 3rd because that's what's inside my square root, or 4th root, sorry. But then I'm going to change my 4th root to the 1/4 instead. I'm going to do it sideways. There's too much stuff going on. So I'm gonna just write that real quick. I'll leave it like this, right? So all I did was change my radical from a 4th root to the 1/4 power instead. I'm gonna do the same thing in the denominator. Again, because this is the 7th root, it's going to be the 1/7 power instead. Okay? So 5th. So here I just have 1/7 like that. Okay, so whatever root you have, the 5th root, the 20th root, whatever root, it's just 1 over that number. So 4th root is 1/4, 7th root is 1/7. Now I can apply my law of exponents again because of a power to a power. It's 3, it's x to the 3rd power to the 1/4, x to the 5th to the 1/7. I need to multiply them. Okay, I need to multiply for a power to a power. When I multiply, I'm going to get 3 over 4 in the numerator. In the denominator, I'm going to get 5 over 7. Right, because what I have is 3 times 1/4. 3 times 1/4 is 3/4. 5 times 1/7 is 5/7. This is the part that you may not remember, okay? But I need to now subtract my fractions because I'm being divided, right? I have x to something divided by x to something. So I need to do 3/4, whoops, 3/4 minus 5/7. Okay, that's what I'm looking for now. It's kind of like my side work. 3/4 minus 5/7. I need to find a common denominator. In this case, you should find 28 because 4 times 7 and 7 times 4, they both give you 28. So 21 over 28 minus 20, oops, 20 over 28. Now that I have common denominators, I can subtract directly. So I get 1 over 28. Because 21 minus 20 is just 1. 21 minus 20 is 1. And so my final answer, let me change this to another color. This is side work, purple. So my final answer then is just x to the 1/28. Okay. Now I understand this number is, to us, even to me, is kind of like meaningless, right? Like, what the heck is x to the 1/28? For now, don't worry about it. That's just kind of like what the end, that's just what the solution is, right? But that's okay, because as long as we can find it, that should be okay. All right, so there's just two things that you need to know here, right? Again, we need to be able to change our radical to an exponential. It should be a fraction where we have a radical. The other thing that you might not really remember is operations with fractions. Okay, so make sure that you know how to subtract or add in terms of your fractions, okay? The last question, what I would do is to first try to simplify the best that I can and then change it to radical form. Okay, so I'll simplify as much as I can and then change it. So what I mean by that is, since I have an exponent on the outside, let me go ahead and distribute this to each of my things first. All right, so I'm going to distribute this to my 9, to my u, and to my v. So that I get, so I have 9 to the 1/2, u to the 2 times 1/2, as well as v to the 10 times 1/2. The reason for this, because I can simplify these pretty easily, right? 2 times 2 times 1/2, 10 times 1/2, those are easy stuff. Because 2 times 1/2 is just 1, and 10 times 1/2 is just 5. Whoa. Because now that I have that done, I can say, well, these guys don't need a radical because these are all whole powers. These are fine. There's no fraction, there's no anything to worry about. These are good to go. The only thing that needs a radical is my 9, because it's to the 1/2, right? But again, remember, 1/2 is just a square root, right? If I had a 1/3, it'd be a cube root, right? So this is going backwards. I'm just going backwards. And so this is going to equal to, I'm going to write my things that are not inside the radical first, just so it doesn't get kind of too messy, hopefully. But because the 9 gets a square root, I'm just going to put a square root 9 at the end there. Okay, so this will be what I have finally. If you wanted to write it in like this variables after the 9, just be careful not to extend your bar out. That's the only thing I would say. Okay, so I'm going to pause there for a second. Again, if I can just get a quick, how we feeling? I'm guessing most of us still feel like, okay, if I can see more examples, that would be best. Okay, can I get a thumbs up, thumbs down on what we just did? Yeah, I figure we would probably want to see a little bit more examples. I think about we have about half and half is what I think. Okay, so I would say tonight, what I'm gonna do is I'm gonna get everything, get the first part of the formative review done. Okay, so if you can, in the review, try your best on, come on. Try your best in looking at this page. Okay, I think I already have this page done. Almost done. I have 3 more problems. Wait, no, I'm done with it. Yeah, I'm done with this page, so I can upload this later. Okay, but I'm going to show. You can see I'm showing all my steps for everything. Okay, so if you can't come in tomorrow for support, definitely do this page at the very least. Review 1. Okay, go ahead and try to simplify these for yourself. Okay, there's a second page here. I'm going to do this in a little bit. I think I'm almost done with this page. Yeah, I'm on the bottom part. Okay, so I'm going to have this top part done also. Okay, do your best to try them for yourself. Okay, if you have not done homework 10, there's also a lot of, I think there's a lot of good examples in homework 10 as well about simplifying radicals and so on and so forth. Okay, we can maybe talk about homework 10 during the support tomorrow, so you get the correct answers for them too. Okay, so please, I'm begging you, if you need more examples, please come in tomorrow during support. Okay, on Wednesday I talk about general stuff, but I probably won't go into too much detail because the test would have been released already. Okay, now just in case you don't know exactly what I'm talking about in terms of what the formative will include, you'll include the things that we talked about today, include the powers of laws of exponents, talk about rational functions, I'm sorry, rational exponents. Okay, there's going to be some graphing on your radicals, your square root and cube roots, right, and key features as well. And the last thing really is going to be like the rate of change, average rate of change stuff. Okay, so it is a kind of a big topic, but all of it kind of revolves around like square roots and radicals. So again, if you need help with any of this, please come in tomorrow. I will do my best to go over everything, okay? Yeah, support is 9th period, which is after 8th. Okay, I know this is a lot. I understand it is a lot, but I'm just trying to prepare you as best as I can. Because I don't, again, the county's like it is what is it? Like there's a certain timing, and I'm trying to help you guys the best that I can. Okay. Okay, and again, if we have time, we'll come back to it today. Okay, but just so again, this is kind of like I said, the 3 types of law of exponents. There's just you gotta memorize it. This is the 2 rules that I would memorize. These 3 I think are easier because if you write it out, it makes a lot of sense. Right, so when you multiply, you add, divide, you subtract. When it's a power to a power, you multiply. Or the distributive, this is like the same rule, but just one's being multiplied, one's being divided. Right? So this is our 7 rules, but really it's like 3 types in my mind. And of course, I just talked about our exponents. If I have a radical, there is a exponent version of it, right? So if it's the 5th root, I have 1/5. 4th root, 1/4. If I have the 20th root, it is the 1/20th. Okay. Now I do think what we're going to be doing today is a little bit easier because it's kind of just like our word problems almost. Okay, so today, like I said, we're going to be solving radical equations, but it is very important for us to check our answers. You're going to see why after we do 2. Okay, so let's solve what x could be in this equation. Okay, hopefully we all know our inverse operations. If I have a square root, what's the inverse operation of a square root? The square, exactly, right? In order for me to get rid of it, I got to square it. All right, so I'm going to go ahead and square this on both sides. The square is going to cancel out my square root because it's the inverse operation. So I'm just left with the x on my left-hand side. And on the right, 99 squared is, of course, 81. Okay, so we say, okay, the answer is 81. But we have to check to make sure that works. And now I copied the problem onto this side because I want to show you what's going to look like if it was instead a, whoops, a fraction exponent instead. Because I know from the previous page, it's the same thing, right? These two are the same thing. So the same operation should do the same as well, right? So I'm just doing this to show you that, okay, they're really the same operation, and this is why it's true, because I can still do the same thing. I can say, well, in order to, like, how do I get 1? Well, to get 1, I need to multiply it by 2, right? So I'm going to bring it also to the second power. Whoa. So you see, in terms of the operation that I'm working, it's the same thing. I'm squaring both sides. So you can see 1/2 times 2, because this is a power to a power, 1/2 times 2 is just 1. So actually what happens is these guys cancel the same way it cancels here. Right? So what I end up with is same thing. Actually, I don't even need to copy it because this is the answer right here. It's the same thing. Okay, so I do want to show the two because they're identical, but I want to make that connection between the square root and our exponent, our rational exponent. Okay, so go ahead. Let's take a look at how this works. Okay, so I need to now check my answer by plugging it in to my x and see if it actually is the correct answer. Okay, and again, this one's going to work out, but you're going to see why we need to check on the next problem. Okay, so I have the square root of 81, and what I'm going to do is I'm actually not going to write equals because I'm checking. Because I'm checking to see if it is equal to, I'm going to go ahead and write a question mark for now. So it's like, does it equal? I don't know. Maybe. But as I start to simplify this, I do find that 9 is indeed equal to 9. So then I can say, okay, this is correct. Where is my check mark? I can say this is correct. So therefore, 9 is a solution. Or I'm sorry. So therefore, x81, this is a correct answer. I'm going to go back and I'm going to go ahead and box this. This is the correct answer. So far, so good. This should be pretty easy, right? This is just solving normally, which we've done for our word problems before. But let's take a look what happens in our following problem. Setup is the same, right? It's the same deal. And I'm going to also do this in terms of the 1/2, so you can again take a look at what it looks like. Or you should rather you should be able to see that it's the same type of operation. But just like before, if I want to solve for x, I have to square, right? Because this is a square root, I got to do the same thing. So I'm going to square both sides just like before. Now, the one thing I would say you have to be a little bit careful of here is when you're squaring the -9 in this case, you want to make sure you put parentheses around it because you're squaring not just the 9, you're squaring everything on the right-hand side. Yeah, I'm squaring everything on the right-hand side, so I should put parentheses around my -9. But just like earlier, my square root and my square is going to cancel out. Same thing on the other side. These are going to cancel out because 2 times 1/2 is just 1. So I have x on the left, -9 squared, that's still 81. And that's true on both. Okay. So far, so good? So far, so good? Yay, nay? Okay. All right. Okay, so I got 2 people. Anybody in the Zoom functions? Okay, okay. All right. Good, good, good. Got 3 peeps. 4, okay. Okay. And we will for sure. Okay. But this time, let's take a look what happens, because again, I have to check. So I'm going to go ahead and try this and see what happens. The problem now is the square root of 81. This is equal to +9, not -9. And so in this case, I would have to say that where is my, is there not, where is it? Am I blind? Not equal to, where is the not equal to sign? Oh, there. Pretty sure there is one. Well, that's not super important. If I find it, I find it. If I don't, I don't. Sucks to suck. But it means then it does not, oh, here it is, I think. Nope. This is awesome. Well, whatever. I'm just going to do my own cross out. Oh, wait, is it there? Let me see it. You saw it. Yes, found you. Thank you. Sorry. Somebody was trying to help me. Okay, but it does not equal this time. In fact, this is the only solution that I get. I get x is equal to 81, but 81 does not work. Okay, and just so you know, because I know that we do this a lot, when we take the square root, in this case, we're all going to take the positive version. The reason being, the reason is, remember how we did our graph? Right, our graph looks something like this, right? We only take the positives because of our graph, okay? Because of this, we do not take the negative version of 9. So in this case, when we check, it does not equal. In fact, this is the only solution that I got, and it doesn't work. What I would say is there is no solution. Okay, this is something we call extraneous solution. This is called an extraneous solution. Extra. It's an extra solution. This is not a real solution. Okay, this is called an extra solution. Extraneous solution. This is not a real solution. So in this problem, there are no solutions. There is no solution. You can equivalent. You can also say does not exist. That's also a possibility. Okay, either one. We have to say that there is no solution or it does not exist. Okay, and we're going to look at a few more examples. Okay, does this make sense, what we're doing here? Okay, all right. But it's, and I will say, remember that for our cube root, right, our cube root exists everywhere. That one, normally you don't have to check because usually like there's a positive and a negative, but for my square root, it's not always going to work. So it's especially important for you to say, I have to check for square roots. Okay, so something like this, like we should check afterwards. We should check afterwards. Okay, so I don't know why an S came up. So let's go ahead and try this. Now, at this point, if you're like, I'm gonna go ahead and try for myself, like that's wonderful. Okay, I would love it for you to go ahead and try for yourself. But again, I'm gonna do my best to show, and I don't know how I'm gonna I'll do my best. I'll try my best to say like, okay, what's the square? What does it look like when it is a this version versus the other one, and so on and so forth. 2x minus 6 to the 1/2. I think this will be the last one I type out both because it's a little bit hard for me to do both constantly. 2, and it is what? X plus 10. I didn't really think about having to do both. To the 1/2. Which one? Sorry. Like what I'm doing here? I'm just rewriting it because this is a square root, so I wanted to show you that it's the same thing as the 1/2 power. That's all I'm doing. Yeah. So I'm not changing anything like in terms of the problem that's being asked. It's the same thing. Yeah. Sorry. Okay, but it's just like before, because I have a square root, I need to square both sides. And what's nice is the whole thing is like the square root covers everything. So my square is actually going to cancel out the whole bracket. Oh, that didn't even go through. Okay, so so all I'm going to be left with is just the inside portion of both. Right, and that's going to be true on this. Maybe I'll just do a different color this time because they're just too close to each other. But same deal here. If I square this as well, my square and my 1/2 is going to get canceled out. Okay, so again, like I said, this will be the last time I do to show you that they're the same because I think it takes up too much time just typing it out. But you can see that this is the same deal. 1/2 and the 2 is going to cancel out. And Zoom is blocking, so I have to move this guy real quick. Right, so the steps are identical, which again shows the square root and the 1/2 power is actually the same thing, right? But regardless which way you think about it, they end up being the same. Oh my gosh, that was awful. Jeez. Okay, but it ends up being 2x minus 6 is equal to x plus 10. X plus 10. Either way, no matter how you look at it, whether the square root or the 1/2 power, you get this. Here, we should be very familiar with how to solve, right? Now I just have the normal, it's a two-step equation. Add 6 to both sides to get rid of the minus 6. So that I get 16 on the right. Then I subtract x on both sides so that x is equal to 16. Okay, so this one looks a little bit harder. I do agree this one does look a little bit more challenging. But I think if you look at the steps are actually identical to what we did last time. All I did was square both sides. This time I just ended it. This one's a little harder because I do have to take this to the next step, but you know how to solve this from Algebra 1. You know how to isolate your variable. I have to first put my constants together, and then I put my variables together. If over here I had another like 2x, I would have to divide, so on and so forth. But this part you should know how to do already. But the idea is the same thing. Because I have a square root, I just have to square both sides to get rid of the square. But again, I have to go back and check. Okay, I have to substitute in my 16 into my 2x's to see if it works out or it does not work out. Okay, so let's go ahead and do that right now. Maybe I would do it on another page because there's a lot of stuff happening. So let me just erase or delete all this stuff because I have this to be true already. Okay, so I already saw that x is equal to 16. And so from here, I'm going to go ahead and substitute in x for 16 and see if it is true or not. And I shouldn't have the equal sign, I should have a question mark. Because again, this is the checking process. Is this true? Is it not? From PEMDAS, I know I need to first multiply. So I'm going to go ahead on the left-hand side, 2 times 16 is 32. On the right, I can go ahead and simplify this. So I don't actually have to, I don't have to only do one side. I can do both at the same time. As long as I get the same, like I just have to do them independently, right? Whatever I do on the left-hand side, I'm simplifying that side. Whatever I simplify on the right, I simplify that side. 32 minus 6 is going to give me 26. So in this case, this does work out. They do equal each other. So I'm all good to go once again. So this, and you can see, like, I'm not trying to find a final, like, decimal number. In this case, I see at some point they equal each other. I can stop. I don't have to keep going. So the square root of 26 equals 6. Like, that's obviously true. So therefore, I'm going to go ahead and say the answer is x is equal to 16. Okay, so this one was a little bit more challenging because there's a couple extra steps, but it should not be outside of what we're able to do. Okay, was this one okay? Still not too bad? How we feeling? Okay, I got one thumbs up. Got another thumbs up in the chat. Got an eh. Got a couple more thumbs ups. Okay. And that's okay. We still have a little bit over 10 minutes. We can go do a couple more problems. I got 2 ehs, but that's okay. I'll take eh. Got 3 ehs. That's all right. I'll take those. I take those. We take those. Okay. That just means we're not there yet, but that's okay. We're going to get there. We're going to get there. This one looks different. But this is what I was trying to show you earlier, right? I actually prefer powers in terms of rational powers because I can just see the number really quickly and solve. Here you just first see with the power fractions, is that right? Yeah, I know, but that we're gonna work on these a little bit. Hopefully you'll feel better by the end, okay? So here, but the steps to isolate my x is just like what I've been doing for, let's say, like 2x plus 4 equals 7. Same thing. Same thing. Pretend for now this is just like a 2x or something, right? Or just ignore this the square or the 1/3 power for now, because the steps are the same. What I'm going to do first is this minus 4. I got to get rid of that first. Okay, just like if I had to isolate my variable, I need to first get rid of this guy. So what I'm going to do is I'm going to add 4 to both sides. That's the first thing I'm going to do. After I add 4 to both sides, I'm going to get x to the 1/3 is equal to 10. That's all I did. Now this is the part that's new because we haven't really like done these a lot. I understand that. But we're using what we know about the law of exponents. Okay, we're going to use what we know about the law of exponents. How do I get 1/3 to become 1? Well, I know 1/3 of 1, I need to multiply by 3. Right? So in order for me to multiply by 3, what I'm doing is I'm going to raise this guy. So I'm not going to cube root it, but what I'm actually going to do is I'm going to bring it to the power of 3. I'm going to actually cube it on both sides. Oh my gosh. So what I'm actually going to do is I'm going to cube both sides. The reason why I'm cubing both sides, because now if you take a look, I have a power to a power, I want to multiply. 3 times 1/3, that's going to equal to 1. So these guys will actually cancel out. Do we see that? Does that make sense? Yeah. Right? And that's why I actually like fraction exponents a little bit better, because this makes a lot of sense to me. Negative 1/3 to the third power, you just multiply. It's really easy to cancel each other out, right? So I'm just going to cancel these guys out, and I just end up with x is equal to 10 to the third power, which is what, 1,000? X is equal to 1,000, I think. I hope. But again, now because it's a cube root or the 1/3, it should be okay. But let's make sure. Let's check our answer. So again, instead of the x, I'm gonna use my answer that I just found. So 1,000. And instead of the equal sign for now, I'm gonna put in a question mark because I want to make sure that this actually equals. I don't know they're equal. I'm checking. That's why I'm checking, right? So I'm gonna see if they're equal or not. The cube root or the 1/3 power, if you need help with that. Now, here's the other thing that's nice about having the rational exponent is now all of a sudden, like when I'm going to Google, right? The Google calculator, I don't know if Google calculator will pop up. I hope so. The Google calculator doesn't have a cube root. They have a square root. There's no cube root. I'm still sharing my screen, right? The whole screen. All right, cool. There's no cube root here, but what I can do now is actually I can type in. Can I type in here? I can do 1,000 to the 1. Oh gosh. I can do 1/3 like that, or I can just type in Google 1,000 to the power of 1/3, and I get an answer here as 10. If you have your own calculator, of course, go ahead and use that. That's fine too, right? I'm just saying in terms of having a rational exponent, just putting in a Google actually is very nice. So now what I have is I know that this is not that anymore, but this is just 10. And 10 minus 4 is, of course, 6. Right, so 6 does equal 6. Again, we are A-OK, and this is indeed our answer. X equals 1,000. Yeah, makes sense? Not as bad as you thought? Okay, so solving radicals, I think it's not too bad in general. I'll say in general. Okay. Now, I think this will be one of the last things we look at because this is like, what the heck is this? What in the world is this? But like I said, I think rational exponents are a lot easier to work with because this is my thought process. I'm thinking, if I have 3/4, what do I have to multiply it to get 1? This is my thought process. 3/4 times what is equal to 1? My goal is to raise both sides to a certain power, right? So that I get this times this. Well, you can always, here's the thing, you always multiply by the reciprocal. You always multiply by the reciprocal, right? Because if I just multiply this, if I flip it, 4/3, right? This is the reciprocal. 3's cancel out with 3, 4 cancels with 4, I get 1. So even if you have a crazy looking exponent, it's okay because you just take the reciprocal, you raise it to that reciprocal power instead. And so here, I'm going to raise this whole thing to the 4/3 power. Oh, that's not what I meant to do. This is what I meant to do. And maybe I'll just do it sideways. 4/3, and same deal here. This 64, I'm going to raise it to the 4/3 power also. Because of this right here. This is going to cancel each other out. 3/4 times 4/3, that cancels. Again, 64 to the 4/3. Oh my goodness, what the heck is that? 64 caret parentheses 4/3. It's a nice number, 256. Again, if you have your own calculator, that's fine. You can do that, right? But here I have my final answer. X, cancel. X is equal to 256. Again, I do need to check to make sure that this is indeed the correct answer. But in terms of solving, this was really just one step. Just bring it to the reciprocal power. Just bring it to the reciprocal power instead. Again, my check, I'm going to go ahead and substitute 256 into my X, change that to a question mark. Is that true or is that not true? Again, just put this in your calculator to see if it's true or not. 256, I'm going to caret parentheses 3/4, and it is indeed 64. So here I have 64 is equal to 64. Again, I have a check to say this is indeed correct. And so my answer is 256. So whenever you see a weird power, 3/4, 20/19, whatever they may be, right? It's okay. Because it's just a power, multiply, or I should say, raise it to the reciprocal power on both sides, and you are good to go. Because they will cancel each other out. The other side, you might get some ugly number. That is possible. That is possible. In this case, it kind of worked out nicely. Okay, I'm going to again pause here. How are we feeling? Can I get a thumbs up, a thumbs down? Or if it's a we'll take N's. We'll take N's. Okay. And we do some more examples so you can take a look again, and that's fine. Okay, it looks like the people who have responded seems generally comfortable. Okay, I think we'll do one more. Let's do this one, because this one is again kind of scary looking, right? But I think it's okay. Again, because I'm raising it to 2/3 power, I'm going to raise everything left side and right side to the reciprocal power instead. Because this is the 2/3 power, I'm going to raise it to the 3/2 power in order to get rid of it. 3/2. I'll just do it this way, just so it's not too cray-cray. But maybe on this side, I can do this 3/2. Woo! 3/2. Okay, so whatever power you have, just raise it to the reciprocal. Someone said we use PEMDAS in order to solve it. So when you solve, you kind of have to go reverse order, right? Because here, if you take a look, this is one step, so there's nothing to do there. But for this, like, we have to first add 4 to both sides, right? Because like if you were to look at this normally, you would say, okay, because there's an exponent, if I've had a 5 here, I would take the cube root, then -4, does that equal 6, right? But because now we're solving, I kind of have to go in reverse order because I'm going backwards. I'm trying to solve to understand what x is going to be, right? That's why I first added 4, the inverse operation, to get x to the 1/3 is equal to 10. And again, I'm going to take the cube because I'm undoing everything, right? Just like how we talk about the inverse, right? We're undoing them in order to solve. Same thing here. Because my parentheses, I can't do anything here. The only thing I can do substitute is my exponent. So again, I'm doing the reverse order. I'm going to first get rid of the exponent. And then after this is done, so the next step, what I'm going to do is I'm going to get, so it's x minus 7 remaining, x plus 7, sorry, x plus 7. And then I need to figure out what 16 to the 3 halves is. 16 to the 3 halves. 64. 64. And then from here, I can subtract 7 on both sides. All right, so my x is then equal to, what is that, 53? I think. No, what am I doing? 57. 57. Sorry. I apologize. Brain fart. Yeah, so the opposite of the radical or the square root would be a square, right? So here we're doing the opposite. We're inversing whatever this is. So because this is to the 2/3 power, we're going to raise it to the 3 halves. So these are inverse operations. I know it's 16. Last thing I'm going to do is I'm just going to go ahead and substitute to make sure this is okay. Okay, so x, let's try it out for 57. Does that work or does that not? Again, I'm going to change my equal sign to a question mark. 57 plus 7 gives me 64. I'm going to bring 64 to the 2/3 power now. 64 to the 2/3. I hope I typed it in right. I did not. 64 to the 2/3 power. I get 16. So 16 does in fact equal 16. Boom. So my final answer is x is equal to 57. Okay, so I hope solving radicals, I hope what I said makes sense. I don't want to take up any more of your time. Tomorrow support, come in for help if you need to, ask any questions that you have. Okay, we'll go over all of them if you want to. All right. If you want to ask any questions or you want to go over a couple more, just, I know during this time we can go over a couple more just so you can see more examples. It's fine with me. If not, have a great lunch. I'll see you either tomorrow or Thursday. Okay, bye, Jennifer.
Bye.
No problem, Jelani. Bye, Melissa. See you guys. Oh, whoa, everybody dipped out. Okay. All right. So, Anessa?
Yep.
Hello. How are you doing?
I'm good. How are you?
I'm okay. It sounds like so let's take a look at your you want us to take a look at your grades first, right?
Yeah, I just need to know, like, are you like are you like keeping up with it? Because like some like my other friends are saying like, oh, like he just didn't grade this or that or whatever, like, or is it
Yeah,
me?
I put everything in last Friday, and why is my login not working? Am I typing
Maybe
this
there
right?
is some stuff that I didn't do, but on the thing it just says like no missing assignments. So I just need to know like what I need to do.
So I think part of it was because that first test was, I know it was kind of rough.
Yeah.
Um, so that I think is bringing it down a little bit. But let me take a look real quick. Let's see if there's anything we can do. Okay.
Okay.
Okay. So that you are currently okay. So you're currently at a 65 about. Can I have, okay, that's a little bit more helpful. Okay, that's okay. So I don't know if you have any more retakes for some of your checkpoints. Do you know you still have retakes for those?
Oh, okay. Did not know that.
I don't. No, I don't. Do you? Do you? I don't know. Do you?
Oh yeah, I think I do. I just think I would just wanted to like get it over with, I guess. Not get it over with, but just like be done with it, if you know what I mean.
Yeah. No, I completely understand. So, if you give me like 2 seconds, let me look
Am
at
I
your.
missing like any homework, like homework 9, homework 10? Like, cause I don't remember if I did all that or not because like the amount of, I'm not saying it's just you, just the amount of work that I have, it's harder to keep tabs on like what I did and what I didn't do.
No, I completely understand. For you, so I haven't put in 9 and 10 yet. I see that 8's not done, but it might be. Oh no, I'm sorry, 8 is done. You are not missing any homeworks as far as I can see. Oh, you are let me see. I really hate this new system. Okay. So homework 5, I think you're, okay. I don't know if something's wrong with Desmos or it's like students are just not finishing it. I see that you did partial on homework 5, but it's only 1 point. I don't think it's going to affect your grade that much.
Okay.
So if you don't want to go back and look, I completely understand. It's literally 1 point. I haven't put in 9 or 10 yet, so I don't know. But I would go back and take a look at your checkpoints. So I'm actually gonna, if you give me 2 seconds, I'm going to look at your checkpoints to see if you've done them all, / if you any more retakes. Okay, so it looks like checkpoint 1, you still have 2 retakes left.
Okay.
Same with 2. Same with 3. So it looks like every single time you took it, and that was it. And that's okay. But you do have opportunities to retake those, and I'm not gonna, not let you do that. So you can still do that if you would like.
Okay, thank you.
And checkpoint 4, I see that you have not done them. I understand, and I don't think it's even due yet. I think it's due tomorrow. Yeah, checkpoint 4 is due tomorrow. So
Okay, I'll do that today.
okay, so retake the checkpoints. If you have questions, I'm okay answering them because you already took the test. So it's like kind of like whatever. But so that's a total of how many points you can get back. That's 4 plus 3, 7, 8, 9, 10, 11 and a half more points that you can get back. I don't know how much that'll bring your grade up, but it should help a lot.
Okay, great. Thank you. I just needed to ask because my mom.
No, I understand. I understand. Now, what about today's stuff? Because you said you were lost, and
It's just like the amount of steps that there is. I'll try to join like your thing tomorrow because I do need to like understand what's going on. Obviously, it was just like I get it, but I just need more practice. If you know what I mean. Like I get it in general, like what we're doing with it. I just need to see like more examples and like do it myself.
Yeah. Do you think today's solving stuff makes sense at all, or is it still like
it helped a lot. Like it's still like I like again like I get like the gist of it. I just need like more like examples.
What about like, so I know that you also said like law of exponents as well as like exponential form versus radical form. Like, I don't know if what we're doing today helps that necessarily, but do you feel more comfortable with that stuff or with solving, or they're both about the same?
I think solving more.
So solving you feel a little bit more comfortable with.
Mm-hmm.
Okay. I mean, that's good because I think solving hopefully is a little bit easier. I do hope that's true.
Yeah.
If you can come in tomorrow, maybe also Wednesday. I don't know if you're able to do that. I know that's a lot to ask. If you're able to come in, that would be great. And, I can give you a little bit more guidance, like one-on-one, assuming nobody else is here, or just seeing more problems,
Yeah. Thank you so much.
Yeah, no problem. Okay, I'll see you hopefully tomorrow.
Have a good one.
You too. Bye.
Bye.